Hello everyone, this is Mrs Pillay, and this week we're going to be looking at 2D shapes. We're going to be thinking of properties of 2D shapes, symmetry and right angles. First we're going to be looking at some properties of 2D shapes. These are the common shapes that we've been looking at school, and we're going to look at how many sides, corners or vertices they have. Remember to use the correct language when you're describing the properties. So first of all, I'm going to look at the first shape, which has one curved side. And it's really important to write that down because that's also a property. So I'm going to write one curved side. And then I'm going to look at how many corners there are. Now I can see there are no corners there, so I'm going to put 0. Can you remember what that shape is called? Yes, it's called a circle. I'm going to write the word in there. Next one, I'm going to count the sides and draw lines so I don't make a mistake. 1, 2, 3. Now, I can see that these are not curved. They are straight sides. So I'm going to write the word straight there because they are straight. Let's see how many vertices or corners they have. 1, 2, 3. I'm going to write 3 there. Can you remember what that's called? Yes, it is called a triangle. I'm going to go to the next shape. I'm going to count the sides by drawing the lines. 1, 2, 3, 4. Again, there are 4 straight sides. But there's something even more special about these straight sides. If I measure those, all the sides of a square are equal. So I'm going to add that there by the sides to remind myself that they are equal in length. Now I'm going to look at the vertices. 1, 2, 3, 4. And write 4. Can you remember what that is called? Yes, it is called a square. Let's go to the next shape. Got 1, 2, 3, 4. Again, straight sides. And what is special about these straight sides is opposite sides are equal in length. So you've got 2 long sides and 2 short sides. Let's count the corners. 1, 2, 3, 4. 4 corners. Do you remember what that one is called? Yes, it's called a rectangle. Let's go to the next one. 1, 2, 3, 4, 5. We've got 5 straight sides. And then I'm going to count the corners. I've got 1, 2, 3, 4, 5 corners. Do you know what that name of the shape is? Yes, you've guessed it. It is a pentagon. And my last shape I've got is 1, 2, 3, 4, 5, 6. It's got 6 straight sides. And it's got 1, 2, 3, 4, 5, 6 corners. Can you remember what that might be called? Exactly that. It is a hexagon. I want us to look at something really special now. Just thinking about the pentagon, the hexagon, and another shape called the octagon. So if I go to my pentagon, I'm again counting 1, 2, 3, 4, 5 sides. And I know it's a pentagon. The next one, 1, 2, 3, 4, 5, 6 sides, which we know is a hexagon. 1, 2, 3, 4, 5, 6, 7, 8 sides, which is an octagon. Now, what is very special about these 3 shapes is that each side is the same length. So all 8 sides here are the same length, all 6 sides are the same length, and all 5 sides are the same length. So if I go to the shapes at the bottom, we've got 1, 2, 3, 4, 5. That's still 5 sides, but it doesn't look like that. So if I look, it's still pentagon because it's got 5 sides, but this is a regular pentagon, and this one is irregular because the sides are not the same length. Let's have a look at our next one. We've got 1, 2, 3, 4, 5, 6. Doesn't look like my hexagon, does it? But all these sides are the same length. Whereas if we look at this is definitely not the same length, each of the sides. So we've got a regular hexagon there, and this one is an irregular hexagon. We've got 8 sides there, which are all equal in length. Let's count if we've got 8 sides here. 1, 2, 3, 4, 5, 6, 7, 8. So we know that these are not equal in length, but those are. So that's a regular octagon, and that is an irregular octagon. You need to keep this in mind when you are doing some of your work for task 2 and task 3. The next part I want to move on to is symmetry. Now, symmetry is when we draw a line down the middle of the shape, or it could be a line across a shape, but making sure that both sides are exactly the same. Both sides has to be exactly the same. We call this a mirror image of itself. So you can have a go at finding symmetry of shapes by cutting out the different shape, fold them in half so that one side is the same as the other. When you open it up, you'll see that the fold, which is this line, is the line of symmetry. You can have a go at doing that at home. And then try to see which shapes have more than one line of symmetry. So you can fold it in the opposite way, checking if it's exactly the same on both sides. I've got a few other interesting shapes that I've looked at here to see if we can find line of symmetry. So if I look at these, I can see the butterfly has a line of symmetry. It is symmetrical. The telephone we've got here is symmetrical, and so is the square. However, the capital G, we can see is not exactly the same on both sides, so that is not symmetrical. The snail is not exactly the same on both sides, so that is not symmetrical. If I look at the star, I can see that's exactly symmetrical. So is the capital H. You can have a go, see if you can find shapes around the house, or see if you can draw a shape and make it exactly symmetrical. It can be one of the letters of the alphabet, for instance, like the H. Which other letters are symmetrical? Have a go and see. The next thing we're going to be looking at is right angles. Now, when we've looked at right angles at school, we know that a right angle is part of a square. If you can see that, it looks like the angle, the corner of a square. And if you look at the kite here, you can see that is the same over there. Now, we have learned to make right angle checkers in class. And if you just draw a circle and draw a line to the middle, so if you look at it like a clock, you've got it from the middle to the 6, from the middle to the 3, and you'll get that exact corner in there. I've done one already, which I'm going to show you now. If you look at it, that's what it looks like. So it just looks like you cut out the mouth of that shape. And that angle there is 90 degrees. But I'm going to show you how we're going to use that to find if there's a right angle on shapes. So I've got a square over there, and if I take my right angle checker and I put it exactly on there, you can see that that angle is exactly a right angle. I can try it on another angle of the square, and I can see my right angle there. However, if I try it on the triangle, let's see if the triangle has got a right angle. Now, if I look at that, it does not fit there. So we know that triangle does not have a right angle. I'm going to have a look at this triangle now. And I'm going to turn my right angle checker a little bit. And I'm going to see, can it fit in there? Yes, it fits in exactly. So we know that triangle has got a right angle. So we'd call that triangle a right-angled triangle. I'm going to have a look at one of my other shapes that I've got here, which might be the semicircle. And if I put my right angle checker there, I can see that that's not a right angle on the semicircle, as is the same when I go to the pentagon. I put my right angle checker on there, but I can see it's going past it, so that has not got a right angle. So although I can look at a shape and I can see, for example, that I can see a right angle there, I always need to make sure and check it. So I can check it and make sure it's a right angle. So I want you to have a go and make sure when you've got some shapes, see if you come across any right angles on your shapes. Enjoy the work this week and hope this lesson is going to be helpful to you. Take care, keep safe.